In this, we'll try to come up with the formulas for LSA, TSA and volume of a cube. So cube is a box which has square shapes on all sides. Just remember square shapes on all sides. So what have we learned in previous standards? So what you need to know is area of square. So what is area of square? Which is a into a, which is a square. So area of a square is a square. So now coming back to this, when I said cube is a box, which is a three-dimensional box, and all the sides are square. So let's take one by one. ABCD. ABCD is a square. The area of that is going to be a square. And similarly, EFGH. Area of that is a square. So similarly, what happens? ADHE is also a square. BCGF is also a square. And then two more sides, ABFE is also a square, and CDHG is also a square. So if you look at this, these two are left and right sides, and these two are front and back sides, and these two are top and bottom. So totally how many sides or how many faces a cube has is 6. So that's what we have written. But all the sides or the faces of a cube or a box are actually going to be squares. So we have written all the areas. So coming back to LSA, which is lateral surface area. What is lateral? Laterals are sides. So what are the sides? If I take a box, sides are, which are the sides? These four are sides. This is top and bottom, like ceiling and the floor. So, but these are the sides. So if I take this, if I want to find out the area of 4 sides, I'm actually going to add 4, which is actually going to be 4a square. Similarly, TSA, total surface area. Total surface area. So what I need to, as the name itself, it says we took lateral surface area. If I want total surface area of that cube, I need to add areas of all the faces, all the sides. So which includes the top and the bottom. So in this scenario, what happens? Now if I add those, here I have 2a square, which is 4a square. I had LSA plus another 2a square, which is going to give me all 6 areas of all 6 faces, that is 6a square. Remember, for areas it's always square units. Unit is square unit. In the sense, if I have centimeter, it will be centimeter square. If I have meter, meter square, or square feet. Any unit you use, that will be square unit. Coming back to value, let's think about it this way. If I take a square and I place another square on top or bottom, another square, just think these squares are made up of just cardboard. So I'm actually going to place them on top of each other. So what happens? And in such a way that this thickness is actually going to be the same unit. A, we have taken unit as A, the length as A, so we'll take this as A itself. That's the length, because it's a cube. All edges are going to have the same length, and all faces are going to be square. So if I take this, and what happens? I have to multiply. I already have area of 1 square, and if I stack them on top of each other, what's going to happen? I have to multiply by that times. But here it's a cube, the edge and the height is actually going to have the same length. A square times A is actually going to give me A cube. That's the height. That's my height. Actually, that is the height. Height I am going to multiply by the number of cardboards I've put. So that's a cube. So remember this concept, this height, where I mentioned height, because here height is equals to a units. That's a length because it's a cube and a square. So this will be cubic units. Units are measured in cubic units. If it is centimeter, it's centimeter cube. If it is meter, it's meter cube. So those are the main things you need to know from this.